Question number 26 says, when the wave reflects from a rigid support, then there is a change in first, frequency of wave, second, wavelength of wave, third, phase of wave, or fourth, speed of wave. Dear students, a wave reflected from a rigid support suffers a sudden phase difference of pi, which means that for this question, option number 3 is the correct answer. We must note that option number 1 cannot be the answer because the frequency depends on the source and it does not changes in the cases of reflection or refraction. Option number 2 also does not change because the medium of the wave is not changing, the speed of the wave would remain constant, and wavelength is nothing but velocity or the speed divided by frequency. Since the speed remains constant and the frequency remains constant, the wavelength has to be constant as well. Now let us discuss the question number 27. Question number 27 says, on superposition of two waves, y1 is equal to 10 sine omega t minus kx and y2 is equal to 10 sine omega t minus kx plus 2 pi by 3, the amplitude of resultant wave will be. Dear students, for these two waves, the phase difference between them is 2 pi by 3. The first amplitude and the second amplitude are equal and equal to 10. The net amplitude can be written as under root of a1 square plus a2 square plus 2a1 a2 cos delta phi. This will be equal to under root of 10 square plus 10 square plus 2 into 10 square cos 2 pi by 3, which will be equal to 10 units. And hence for this question, option number 1 turns out to be the correct answer. Now let us proceed and solve the question number 28. Question number 28 says, a tuning fork gives 5 beats per second when sounded together with a sonometer wire having separation between bridges 20 centimeters. It again gives 5 beats per second when separation between the bridges increased to 21 centimeters. The frequency of tuning fork is. Dear students, for a sonometer wire, the frequency is inversely proportional to length. Let in first case the frequency be n1 and in the second case the frequency be n2. Now, since the length is being increased, therefore n2 should be less than n1. In the first case, we can write down that n1 minus n is equal to 5, where n is the frequency of the tuning fork. And in the second case, we can write down that n minus n2 would be equal to 5. Dear students, therefore, from the first equation, we can write down that n1 is equal to 5 plus n, and from the second equation we can write down n2 is equal to n minus 5. On dividing these two equations, we can write down that n1 by n2 is equal to 5 plus n divided by n minus 5. n1 by n2 would be equal to L2 by L1. On substituting the value of L2 and L1, that is 21 by 20, and solving this expression, we find out the value of n to be equal to 205 Hz. And therefore, option number 2 is the correct answer. Now let us solve the question number 29. Question number 29 says, in a resonance column, the tube, first resonance is obtained at length of 17 cm and second resonance at 53 cm. The length of third resonance will be. Dear students, since 53 is not exactly 3 times of 17, this means that some amount of end correction is there. In the first case, L1 is equal to 17 cm and in second case, L2 is equal to 53 centimeters. Dear students, if the end correction is E, we can write down that L1 plus E and L2 plus E are the effective lengths of the resonance column. Now, since they are first and the second resonance, we can write down that L2 plus E divided by L1 plus E should be equal to 3. On substituting the given values, we find out E to be equal to 1 centimeters. Dear students, the effective length of the first resonance therefore is L1 plus E, which would be 18 centimeter. Of the second resonance would be L2 plus E, that will be 54 centimeter. And of the third resonance, L3 plus E would be 5 times of 18, that will be 90 centimeters, and we can find out the value of L3, which will be 90 minus E, and that will be equal to 89 centimeters, which makes option number 3 of this question as the correct answer. Now let us discuss the question number 30. Question number 30 says 20 tuning forks are arranged in series in such a way that each fork gives 30 beats per second with the previous one. If the last fork is one octave lower of the first fork, then frequency of the 10th fork is. Dear students, after each lower octave, frequency becomes half, and of 20 forks, 19 pair will form. Dear students, assume that the frequency of first fork is 2n. Then the frequency of the last fork can be written as n. Dear students, 2n minus n should be equal to 19 into 3. Therefore, n should be equal to 57 Hz and 2n should be equal to 114 Hz. The frequency of the 10th fork can be written as 114 minus 9 into 3. That will be equal to 87 Hz. And therefore, option number 1 is the correct answer. Now let us proceed to the question number 31.